Hello class, welcome to the next section. We talks about the evaluating functions and it deals with the substitution, application and practice. I will plead with you to stay very active because this section deals with a lot of work. Okay, let's move on to the next section. What is function evaluation? What is function evaluation? Evaluation of function means finding the value of f of x for a specific value of x, and it involves substitution and evaluating the expression in an algebraic form. It involves substituting the given value into the function's formula. It shows how input values map to output values. What we need to understand from this section is such that for every function, there is an input, and the input is being processed for it to become output. You input the value x into the function, which serves as a machine, and the machine, which is f of x, will process the input, which is the object x, for us to get the image, that is the results, the output of your input. So that is what evaluation of function x. And this section is very much active and interactive. Let's move on to the next section. Example 1. Given a function g of x equal to negative 2x, we want to use this one to evaluate g of negative 3. When you want to evaluate g of negative 3, here the input is negative 3, which is the object, and the machine is g of x, which is negative 2s. So you can compare this idea with a maze and a blending machine or a mill. The maze becomes the object and the blending machine becomes the function. So when you put the maze in the machine, in the mill will process it for us to end up with an output which is called the condo. That is how a machine works. You input the object into the machine, which is the function. The function will process it in arithmetic and algebraic form for us to get out the output. So for this example, the input object is minus 3, and the minus 3 will be a substitute to the x, and which will be in the form of g of minus 3 equal to minus 2 times minus 3, and minus 2 times minus 3 arithmetically will be 6. So g of minus 3 is equal to 6. Let's move to the next example. Example 2, which is in the form of a fraction, rational function. We have r of x equal to 3x plus 5 over 7x minus 14. So now there is our machine, and we want to evaluate the output when we input 3. So the object 3 will be inserted into the machine, and the insertion will be in the form of substituting x as 3 as shown below. So we work out with an arithmetic operation here. 3 times 3 will be 9 plus 5 divided by 21 minus 14, which will give us 14 out of 7 equal to 2. And the results or the output when the object 3 is inserted into the machine, which is R of X, the results is 2. The output is 2. So we can also say that the image of 3 is 2. Let's move to the next section. Example 3. If g of x equal to 2x squared plus 3, we want to evaluate g of 3. The same process, the input. Then we process the input by using the machine g of x, which is 2x squared plus 3, for us to get the output 21. Another example, with the same scenario, we have g of minus 8, which will be equal to 2 into bracket minus 8 squared plus 3. And minus 8 all squared will give us 64, and 2 times 64 will give us 128 plus 3. And the final answer will be 131. So when you input the object minus 8, the output will be 131. So we can also say that the image of minus 8 is 131. Let's move to the next section. And the same principle can be used to evaluate the g of x from the previous section algebraically. So here, your input is an algebraic expression a plus 1. So it means that when I go to the machine, I am going to input an algebraic expression a plus 1. And this one will be anywhere I see the object x, I'll substitute the value of a plus 1 into the object. So that will give us 2 bracket a plus 1 all square plus 3. And when you expand it, this one becomes a perfect square. So perfect square expansion, it will be you take the a square, that is a square here, then 2 times a times 1, that will give us 2a. Then 1 square will give us 1. Remember, we have to expand this perfect square before multiplying the constant with this 2. Then the other constant here is plus 3. Now we can expand the bracket. So expanding the bracket will be 2a squared plus 4a plus 2 plus 2 plus 3 rather. Then we group like terms here. So grouping like terms will be 2a squared plus 4a plus 5. So if you can realize that 2a squared plus 4a plus 5 is the output when you input a plus 1. So a plus 1 is the input with the 7 as the object. Then its respective image will be 2a squared plus 4a plus 5. Let's move to the next section. And the next section talks about how we can evaluate with a coefficient. So here with the same scenario of g f squared plus 3. Here we have the coefficient of 3, which it is multiplying g of 5. It means that we have to input the object 5. And after your input, the machine g of x will process the object 5 for us to get a result. After that, the coefficient to multiply the results. So here it will be 3 bracket 2 times 5 squared plus 3. So you see the coefficient here is not working now. It is, we have to finish the bracket before we multiply the coefficient. So 5 squared will give us 25. 2 times 25 will give us 50 plus 3, that is 53. Now the machine g of x have been able to process the object 5 for us to get the image 53. Now we are going to multiply the coefficient, which is 3 to the 53. That will give us 159. Let's move to the next section. We have an advanced example here. You can try it yourself. Then you substitute the results for you to get using the same principle for you to get respective the answers that is being given to you. Let's move to the next section. Now we are understanding, we've got to the understanding of the evaluation of functions. Now let's apply it in a real life example. I can use this one as a taxi fare. When you take a taxi, so a taxi fare is calculated using the function f of x equal to 5x plus 10, where x is the distance in kilometers. So like you want to take an Uber taxi, and we've been able to model the function that determines your price based on the kilometers. And the function is f of x equal to 5x plus 10, where x is the distance in kilometers. So first, we want to find the cost of 6 kilometer trip. You want to travel at a distance of 6 kilometers. What amount are you going to pay? Here we learned that x is the distance in kilometers. So if I want to travel 6 kilometers, it means that the input is 6. So anywhere I see x, I will substitute the 6 kilometers here, and that will give us 5 times 6 plus 10, which is 30 plus 10, and the result is 40 cedis. It means I'm going to end up paying 40 Ghana cedis based on the modeled function as a machine. Good. Let's move to the next example. We can also move to a real life mobile phone billing. A mobile phone billing is calculated by using the modeled function b of x, where x is the number of minutes used. So the b represents the mobile phone, that is the model here represents the mobile phone billing. So find the bill. So the b of x is the bill, the b is the bill. So find the bill for 100 minutes of talk time. It means that anywhere I see x, I will substitute the input, which is 100 minutes, to see the output, which is the cost when you use the mobile phone for 100 minutes, and the cost will give us 15 Ghana cedis. Then we can also model electricity bill, which is also can be modeled in the form of a function where E represents the electricity bill, and here x is the number of unit consumed, and the unit is in the form of kilowatt per hour. So if a household uses 120 units, then 120 unit means that the input is 120, that is the object. Then if I want the image, which will be the resource, what I need to pay as my electricity bill, I'll input it here, and it will be 0.75 times 120 times plus 10, and that will give a 90 plus 10, which means that when I use 120 units, I'll end up paying electricity bill of 100 Ghana cedis. Let's move to the next section. Real life example here is example about this thing this function modeling can also be grade calculation, which we have the idea already from the lesson 1. So a steady final grade is calculated by we have G X and Y, where X represent the class score, Y represent the exam score, and this one too is a function. So if a class score is 65 and exam score is 80, it means that any student who had a class score of 65 and exam score of 80, using the modeling function here, that is the rule of this particular function, then my input will be 65 and 80, which I'll end up with a respective grade value of 75.5. Then let's move to the next section. This section talks about the try work. So you can use this work, try your hands on it, pause the video, and send me the feedback of your answer. For this section, I have a real life problem for you. And the problem is the delivery fee is calculated as dx equal to 2.5x plus 10, where x is the number of kilometers. So I am urging all of you to be able to solve this particular problem for me. Try your hands on them and send me the feedback on this particular channel to the comment section, or you send it to me personally to my email or my WhatsApp number. Thank you. I'll be waiting for you and seeing you at the next section.